Okay, here is the very last page of your notes from 11.1. So it asks how many different even numbers greater than 300, sorry, I'm going to change it to even 3-digit numbers, greater than 300 can you make using the digits 1, 2, 3, 4, 5, and 6, and no digits are allowed to repeat. Okay, so you'll see here there's 6 different numbers we can choose from. They have to be 3 digits. So I broke this up into 2 cases. So either it's even and it starts with a 3 or a 5. It has to start with a 3 or a 5. It can't start with a 1 or a 2. And we're going to look at if it starts with 4 or 6 in the second case. We're going to look at these 2 cases. Whenever we have cases, you must count the different arrangements in cases and add them together. So if it could be case 1 or case 2, or is that keyword to mean to signal that we do add. When we have the word and, then we multiply. That's the fundamental counting principle. Here, or means add. Okay, so it's either we're going to have a number is even and starts with a 3 or 5, or it's even and starts with a 2 or 4. That's how we're going to go about solving this. Okay, so it's even. So in this very last spot, all the even numbers, there's 3 choices. It could be 2, 4, or 6. Okay, it must start with a 3 or a 5, so there's 2 choices to go here. Again, it has to start with a 3 or 5 to be more than 400, 300. Okay, so there's 6 numbers. I've already placed 2 of those numbers. There is 4 numbers left. Okay, so 2 times 4 is 8, times 3 is 24. Okay, or we could have the idea that it's even and starts with a 2 or a 4. Okay, it actually can't start with a 2, right? The reason it can't start with a 2 is it would not be bigger than 300. So it's even and it starts with a 6 or a 4. Sorry, I made that mistake. A 6 or a 4. Okay, so if it's even, it's going to start with a 6 or a 4. There's 2 choices here. Now I've used up either a 6 or a 4. In order for it to be even, we said it had to end in a 6, a 4, or a 2. Those were the 3 numbers of the 6 we were given it could end with. It needs to end with a 6 or a 2, but we've already used a 6 or a 4 here. We've already used one of these, so we only have either this and this or this and this. We only have 2 choices there. Okay, I have used up 2 numbers out of the total 6, so I have another 4 choices there. Okay, so 2 times 4 is 8, times another 2 is 16. Okay, so because I have either 24 in this case or 16 in that case, I'm going to add them together for a grand total of 40 ways. So there are 40 different numbers that I can make with the digits 1, 2, 3, 4, 5, and 6 that are 3-digit, even, and greater than 300. Okay, so sometimes breaking up into cases is going to be your strategy. The way you get good at counting problems is by doing lots of practice. So do the assigned questions in class with Mr. Ingram. I'll leave solutions with him. The answers are in the back, but I can show the work, so you can always check with him. And then you need to try all the questions you're assigned. I did 1 to 12 because you want to see as many different types of questions as you can. One of the questions will ask you to do a tree diagram. If you'd rather do it mathematically, you can. A tree diagram simply means like how many different ways could you make the outfit? Well, either you could start with shirt 1 and pants 2, pants 1, pants 2, shirt 2 with pants 1, and pant 2, and shirt 3 with pant 1 and 2. And then there was 6 different outfits that can be made. Okay, that's making reference to that very first problem we did. Here, there was 3 shirts and 2 different pants. We said there was 6 outfits you could make. You could also represent that with a tree diagram. Oh, I'm too far. With a tree diagram in this way. This is the tree diagram. It says, well, you've got branches. Okay, so you can do a tree if you want. You don't have to. I'm fine with you just showing mathematically of 3, then 2, 6. Okay,